Hi everyone, I'm İlkay Eke and I'm an industrial engineering student at Bilkent University. And I'm going to carry out my physics 102 experiment. The aim of my experiment is to analyze the resistance and its formula and the relationship between resistance and physical quantities such as length and cross-sectional area in the formula of resistance. From the formula, it's obvious that resistance has a direct proportion with the resistivity and length. However, it has an inverse proportion with cross-sectional area. To give more detail about resistivity, the resistivity is defined as a unique property for each different material. For this experiment, the copper material is used. And the copper's resistivity is compared between the theoretical and experimental values. A circuit is prepared. In this circuit, there is a multimeter, a DC power supplier, a millimeter, and electrical wires. And we have some copper wires as resistors in different lengths and in different cross-sectional areas. And I wanted to show you my setup and my circuit from a different view and in a more detailed way. There are 6 copper wires. 3 of them have a 0.6 millimeters radius and 3 different lengths, which are 30 centimeters, 60 centimeters, and 90 centimeters. The other 3 has the same lengths with others and have 0.3 millimeters radius. It is really hard to measure the copper wire's resistance. That is why we have an extra resistor which has a 29.4 ohms value and connected in series to the circuit. After constructing again and again to get the resistance and after we get the data, analyzing these data shows us that length has a direct proportion with resistance. What I mean is the resistance value increases when we use a longer copper wire. Another outcome is the resistance has an inverse proportion with cross-sectional area. It is obvious that when the cross-sectional area increases, the resistance value decreases. After getting cross-sectional area and length data, the resistivity value can be calculated from the resistance formula. The difference between the theoretical and experimental value occurs because of the sensitivity of measurement tools, especially the milliammeter being so sensitive, occurred this error. Another way to calculate the resistivity is to use the resistance length graph slope. There was again a difference between this experimental value and theoretical value, but this time this difference occurred mostly because of numerical values. I tend to use small digit numbers, that is why an error occurred here. And this was my experiment. Thank you.